what we do is we design and build composite products to solve customers' problems, basically. And then what we're developing here is a carbon fibre wheel. That is not necessarily something new. There are carbon fibre wheels out in the market, and you'll see them on certain vehicles in the marketplace at the moment, and that's something that we've been developing over the years and selling into the automotive industry. But trying to do it in aerospace is significantly harder, and although there are a number of research efforts going on to do this at the moment, no one has actually successfully qualified one and got one flying yet. So if we get this through and working, then it will be a world first. So the GTTC wheel, which is a little bit difficult to say, and that stands for Guided Tow Technology Composite. So it's basically about the process that we use to get the fibres within the composite in the right place. Really, the main benefits principally is about improving the fatigue life. So normally with composites, what is often the main goal is weight saving, whereas that's really third on our list, I would say. So the main benefit is about fatigue. So composites offer us a much better fatigue performance than, say, an aluminium alloy like they use now. The second element is whole life cost savings. So because of this fatigue life improvement, because of less maintenance, because they don't rust or they don't corrode like aluminium wheels do in a salty environment, then we basically make the thing over the life of its use cheaper. A helicopter we think of as light, right? But it's 6.5 tons, this aircraft, and these wheels are quite small. And they're probably half the size of the automotive wheels that we work on. So the load rating on these is really quite large. So it's not easy, and we're having to bring together all of our kind of skills, technology, know-how that we've built up over many decades really, and bring that together into making the perfect composite wheel really. Okay, so this is the GTTC wheel that we're actually looking at. So this is the wheel that or the shape of the wheel as a prototype that we've developed for Leonardo. So this is just to kind of show you the sort of shapes that we're having to deal with. It's this big cup shape. It's also a two-piece wheel, which is not what we normally deal with in automotive. So aerospace, because of their very stiff tyres, need a two-part wheel. And the size of this wheel is advantageous when it comes to 3D printing and rapid prototyping. So that's allowed us to print a full-scale version of the wheel, and also of some of the tooling that we're going to use. So that's been really helpful to enable us to start developing how we get the fibres and the preform together for this product. The way that most of our composite products are made is that we start with fibre in a dry format. We have to, in many different ways, including our tailored fibre placement process, get the fibres into the shape, orientation and place that we need them. And then those go into a closed tool, they're injected with resin, and that's what turns it into a finished composite. So these were preforming tools that we've used along the way that allow us to develop that process for how we get the fibres into that shape, how we get them at the right orientation, and make sure that the strength is exactly where it's needed, that it's not over-engineered in some places, that it's basically the best wheel that we can produce. So one of the things we've had our eye on when developing this helicopter wheel is the future aircraft, or the future of rotorcraft, let's say. So there's this exciting new market known as advanced air mobility, which in the future we'll see as basically large drones like air taxis transporting us all around our cities. And some of those will need wheels, but as well as that, the rotor blades and the propulsion systems for those are a really important area for lightweighting. This is an early concept blade that we've produced, and that will lead into the next project. But one of the key parts for this is being able to produce these at the cost point and the volume that's needed. So the production kind of predictions in this market are absolutely enormous. I mean, the sort of numbers of blades that are needed every year is like the numbers you see in automotive, but that's in aerospace, and that's something that's quite new. So we are kind of looking to bring together the right technologies, including some of the things that we can bring across from the wheels that we've developed, so that we can do these cheaply and at volume, and obviously also lightweight and strong. So NATEP for us is a way to be able to work to get into aerospace and access the support of the ATI, but an SME focused level. So NATEP makes that process much easier. I mean, to go and work on an ATI project, you're talking about a much bigger budget. You've got to be working with, partnering with much bigger companies. And at the size that we're at now, okay, we're growing quickly, but we're still relatively small, and we need that sort of more touchy-feely aspect that NATEP gives, and they give you a lot of support along the way. Really helps with how to run the project and getting that route to market, and that's where the support really excels, I would say. I think if we were to try and do this project without their support, it would have been a lot smaller and would have taken us a lot longer to get to the end goal.
Well, I've been working with Carbon 360 now and supporting them for about 2 years, since they first approached us for potential grant funding, which they went on to achieve. Carbon 360 are a really exciting company. They bring a lot of experience and knowledge to the aerospace industry from other markets, and potentially really disruptive technologies. And so it's been quite exciting to be able to follow their journey as they develop their first aerospace products. To me, it brings real innovation to the aerospace industry. It enables production at scale of a high quality, repeatable product. And it brings technologies and resin systems from other industries that I think are a first for the aerospace industry. So it's got real strong potential for the future.